Welcome to the Geoeconomics Podcast. I'm your host, Aleksa Burmazovic, and today we'll be speaking with Jonathan Nutzati, who is the founder and CEO of a lighter-than-air drone startup called Mothership Aeronautics. He's also working with the Draper Hero Labs. This conversation goes into innovative technologies such as 3D printing and drones that will significantly affect our lives in the next 10 years and how they proliferate, particularly through special economic zones. I think the conversation will be most useful if you want to stay on top of innovative manufacturing and supply chain technologies. And even though the conversation does get a bit technical at times, I think it's going to be a very enjoyable listen nonetheless. Without further ado, here's the conversation with Jonathan. Well, Jonathan, welcome on to the Geoeconomics Podcast. How are you doing today?
I'm doing pretty swell. How about yourself, Aleksa?
Doing well, thank you. So, as mentioned in the beginning of the podcast, you're a resident entrepreneur over at the Draper Hero Institute. Can you tell me more about what that place is and what you do there?
This is a warehouse and makerspace full of entrepreneurs from various high-tech ventures that are affiliated with the Draper ecosystem here in San Mateo. So we've got some companies here that are working on autonomous cars. Some companies are working on flying cars. We have a few companies working on 3D printing and advanced CNC manufacturing. And then our company is designing long endurance drones that are being 3D printed. We're actually looking specifically at attritable drones that can be produced locally anywhere in the world.
Interesting. So when you say attritable, what does that mean specifically?
So attrition is a word that describes sort of the killing of soldiers in an army, but small amounts in small skirmishes. So you're gradually losing units, you're gradually losing forces. The U.S. Air Force defines attritable as trading a low-cost maintenance for expendability. So, for example, rather than have high-cost, expensive components and systems deployed, they would go for systems that sort of minimize that cost such that if it were to be lost, shot down, or crashed, the value of it having been used in that situation in the first place exceeds the return value of it returning.
So how would you compare the words attritable and disposable? Like, what's the relationship?
Disposable suggests that after the first time you use it, you will throw it away. Attritable doesn't necessarily mean you'll throw it away. You can continue to use it. It continues to be a useful product for its lifetime. It's just that the trade-off of do we overhaul it, do we replace it, or oh no, we might lose one in this situation. It's more cost beneficial.
So this is because of the 3D printing aspect, right? So because the parts of this drone that you guys are making, and again, this is Mothership Aeronautics, we'll have the link in the description. Sort of because of this 3D printing aspect of it, that makes the attritable/replaceable parts aspect of this more pronounced. Is that right?
Yeah, the 3D printing element is a major contributor to being able to make these products attritable. In many ways, it's because you can produce very complex plastic and structural geometries with very low investment. You can change the design on the spot. You can be in the field and lose some number of airframes, but produce them in the field without having a supply chain, without having a mold, without having a warehouse. So 3D printing allows for the rapid sustainment element of that process.
So what does it mean to not have a supply chain in situ, so to speak? So, I mean, let's presume that we're somewhere in the outback of Australia and there isn't a factory that can help us create new drones, and we're using the drones for some kind of surveying project or something like that. So, I mean, what does it mean to not have that supply chain, and how does one get, sprung up in the middle of nowhere? How does that work?
Well, you'd still need supply chains. It's just that in a forward operating base, or in a base of an army that is employing multiple different pieces of technology, you can consolidate supply chains. Like if you have 3D printers and the supply chain that supplies those 3D printers, for example, the filament and replacement parts for the printers, you can now print parts for this drone among other parts for other systems. So let's say you have a Jeep and you have parts go out on the Jeep, or parts that need to be replaced on another aircraft or other field equipment. There could be a 3D printing system that can supply all of those, and including provide more airframes for drones. So this is something that is being experimented with marine groups. There's companies called, for example, there's a company called Krator out of San Diego that is supplying field 3D printers for the United States Marine.
So is this usually something that the military sort of leads on, or are there other innovation hubs that this sort of technology starts with?
Well, the military asks for certain technology that they are looking for. They have a system to request, and the Air Force, within the United States Armed Forces, the Air Force has the most modern system for doing this. They have an online portal with which you can access what the different divisions of the Air Force are looking for to solve their problem. And today, if you were to look at that system, you'd see that they are asking for a attritable, field configurable, low C-swap, which is cost, size, weight, and performance. The low C-swap ISR, so that's intelligence, surveillance, and reconnaissance drones. They're looking for that, and then they're looking for technologies to improve rapid sustainment, which is elimination of multiple streams in a supply chain, to simplify the supply chain and have replacement parts and new parts more available to the front line.
So back to the subject of supply chains, we're assuming that there exist, basic supply chains that supply, as you say, the filament for these 3D printers. And where does somebody find out what is the necessary prerequisite for setting up a supply chain? Let's presume that I want to build a new 3D foundry. I guess that might be an interesting word in a remote place. Assuming that I know what I want to make, where do I get the ingredients list for the supply chain that I need out there? Is there like a centralized repository or something that I can look at, or how does that go?
I wouldn't say that there is one yet. This is something that we'd have to be creating today. This is pretty cutting edge as far as having these 3D printing supply chains. I would think that if you have a specific type of printer that can print your products consistently, I would look at, first of all, having replacement consumable parts for that printer. So nozzles tend to be a consumable. Small fans, heat sinks, heating elements, the usual spare parts for the printer, which normally the manufacturer of the printer can provide. Additionally, you're going to want enough filament to produce the parts that you want of the type of filament that you're going to want. And where it gets interesting is equipment does exist, but is not widely used yet. Is equipment that can produce filament from plastic. And that's where it's going to get really fun. When we start to have self-contained production systems that can produce goods, and then when they're disposed, they're turned back into plastic to produce the new goods. So that any unit can be self-sufficient, at least in terms of matter, and you only need to input energy, theoretically.
So, so with the input being energy and with matter sort of circulating within a closed system, does this have a sort of connotations of reducing the role of massive international supply chains and increasing local circular economies?
There's a definite potential for us to move in that direction. And I think a lot of this thinking has resurfaced due to last year's COVID, making us question our supply chains and our ability to move goods and wonder if maybe we should not be so interdependent when on other countries, other supply chains. Each country having supply chains that's so intermingled, you're not even prepared for what you can't have anymore when those supply chains shut down. Most people are not prepared to take into account what they're going to stop getting when the airports are closed, when borders are shut, especially in smaller countries that are heavily dependent on their neighbors for goods. It's important to think about it, and I would say I've been thinking about it, and I think a lot of people have been thinking about it.
So, with a lot of people thinking in this direction, what resources are there for people to sort of get the necessary, training, resources, materials? I mean, there's got to be some kind of platform or something. I'm not saying that there is one, but there should be for people who are into 3D printing, into drone manufacture, all sorts of stuff that we're talking about now, for them to get plugged into this system. Can you say more about like the necessary steps that people will need, like education, etc.?
Certainly, and that's one of the things that Mothership Aeronautics has been developing. We've been developing a course or a system of course that allow various groups to produce drones on their sites using 3D printing. It works in many ways like a curriculum that has first an introduction to the theory of drones, then a secondary class that teaches and instructs how to produce a single drone, and then there's a class that introduces the student to 3D printing. Then finally a capstone class that combines the 3D printing and drone production. How do you produce a drone microfactory? So the idea of the drone microfactory is a relatively new one, but I think that microfactories are going to very quickly become a very important thing in global economics and supply chain.
So tell me more about the microfactory. Is it like a place that produces parts for a 3D printer like nozzles that you mentioned, or does it produce something else?
So microfactories, as many people are imagining them, are going to replace the final level of assembly, or going to perform a final level of assembly, where electronic components in the immediate future are probably going to have to continue to be sourced. But where this consolidates is that in the revolution of electric vehicles, in the electrification of transport, which is a process that's ongoing today. We're seeing not only cars move to electric cars, but also people are riding electric skateboards, electric bicycles, and other electrified transportation solutions. Additionally, we're seeing the proliferation of drone technology, of unmanned vehicles, unmanned rovers, unmanned submarines, unmanned boats, and even urban air mobility vehicles, which are basically electric quadcopters or electric helicopters that carry people from rooftop to rooftop. A lot of this is a trend in transportation and logistics that consolidates certain supply chains. If we're seeing new vehicle production moving to electric, rather than needing so many differentiated components as with the previous paradigm, a lot of the controllers, the motors, the lithium batteries can be shared between products. If you look at, for example, all of the components required to make a drone, a small electric drone, and compare them to the components required to make a human carrying drone or an urban air mobility vehicle, or a unmanned car or autonomous car, some of the electronics and software is consistent and shared across. So the education and training and know-how required to put these things together is shared, and a lot of the supply chain is shared. The things that need to be shipped in a world with microfactories are the smallest things that are unique. That need to be produced in specialized places, like the microchips. But even those, we're starting to see 3D printers that can print digital circuit boards or electronics boards coming to be used by various.
Right. And I mean, what you just talked about made me think of the sort of well-known statistic that in the iron and steel industry, something like 85% of all the iron doesn't even come from smelting ore anymore. It's all scrap iron that gets sort of recycled into the system. And I imagine that the statistics are similar for the aluminium industry, in canning and stuff like that, where where it makes more economic sense to recycle the existing materials as opposed to digging new ones at the earth. I assume that we're not at that point with materials like lithium or the batteries that are going to be powering this electronic and second electronic revolution. So is this going to be sort of a situation where we reach a saturation point of the material extracted from the earth, and from that point onward we move towards more of a circular model?
I really hope that we move towards a circular model, and I believe that there's potential for that to happen. The hope is that the companies are properly incentivized to go for that direction. But if you look at the big shareholders meeting of Tesla, when Elon Musk and Drew Baglino talked about the new batteries and their battery recycling plan, what Elon said was that essentially you're going to harvest, or Tesla is going to harvest the amount of lithium that they need and then put that into circulation and not need large amounts at any time in the future. So they're talking about turning lithium into a circular economy in that way. I believe it should be possible with 3D printed plastics and 3D printed metals, considering that they're primarily thermoplasts. While there may be some degradation each time the plastic is worn down, there is a lot of potential for circularity in that supply chain.
Right. And what it sounds like is that if we are successful in making this sort of new lithium economy be circular and reduce the role that digging up new resources takes up, it sounds to me like the whole lithium geopolitics aspect of things might not necessarily be as influential as some experts pointed out to be. So what I mean by that is a lot of future-oriented geopolitics people are saying that this new lithium economy is going to be obviously driven by new electronics, is going to displace oil as the as the sort of geopolitical strategic resource of choice, and that the conflict areas are going to move away from the natural fossil fuel areas, Central Asia, Middle East, all the sort of oil-rich places, and they're going to move to places with more mineral wealth, like Central Africa or other places. And with this new upcycling model, it sounds like that's going to be much less pronounced if well implemented. Is that sort of right?
There it's going to slow down. Of like land grabs for lithium will probably slow down once the circular portion of this is established. But that technology is still being perfected. Still, I don't know what level Tesla is with that technology, but I don't suspect they have implemented it yet in any way. And in the actual dash for electrification, where I mean, we still see cars, there's still gasoline cars everywhere. I would say the penetration of electric cars I don't have the numbers, but it is not yet the dominant type of car. I don't even think that more people are buying electric cars than gas cars at this time. So it's going to take some years, but over the next 10 to 20 years, the amount of lithium demanded is going to be increasing. But there is lithium in many places. It is the most plentiful element on the earth, but we're going to need to be extracting it. So yeah, I see it as a dash that will be maybe dampened by the cyclical technology that will come out.
Right, right. And regarding that, it sounds like the micro factories that are going to be present around the world. Obviously, many of them are not going to be within close range of the resources getting extracted, right? And even the resources getting extracted, again, talking about the lithium, in places where it's economically feasible to extract them. So let's say the Yadar Valley in Western Serbia or Central Africa, other lots of places around there with economically feasible lithium extraction. These places aren't necessarily going to be close to population centers where the consumption of these electronics and also the recycling and maintenance of these electronics is going to take place. So an interesting story is that back in the Soviet days, when Azerbaijan was part of the Soviet Union, they would extract the oil over in Azerbaijan, but they'd transport the crude oil via pipeline all the way to Moscow and St. Petersburg, where most of the people who consumed the oil lived, and they'd refine it on the outskirts of the city. So I was wondering if you could tell me more about the sort of economic aspect of processing these materials where they're used as opposed to where they're mined. With this new sort of you're talking about hundreds of thousands of drones active in a city, and I assume that means a lot of maintenance. So I'd like to shift the conversation more towards this maintenance economy and sort of what we're moving in that direction.
Yeah, I think that's going to be very interesting when we have a lot of unmanned vehicles, unmanned drones, unmanned rovers operating in their jobs around cities with a consolidation of repair processes, with a consolidation of technologies. If we see unmanned rovers of various companies and unmanned drones of various companies sharing elements of technology, there is potential to produce spare parts and replace those spare parts in cities in which they operate to eliminate the need for shipping of components for service. I see that with widespread logistics. Like let's look at a world where all packages are delivered by little sidewalk robots, and all take out food rather than having a driver, an Uber Eats driver or a DoorDash driver go to a restaurant and pick up your food and bring it to you, a small sidewalk robot will travel from a restaurant to your home. Now, whether or not that sidewalk robot is owned by Uber or owned by McDonald's or owned by Taco Bell, or or it's owned by you and you send your own robot to pick up whatever food you want, any of those models could actually come to exist in our, or possibly all of them. It could be that people buy their personal robot that's compatible with going to McDonald's, or it's compatible with going to Taco Bell, or it can go pick up your Amazon packages. But if you don't, you pay Amazon for delivery and they'll send your boxes in their drone. But all of these worlds are worlds in which there are so many of these small vehicles out and about that if it comes into existence, we're going to have to imagine that these vehicles are going to get hit by cars. They're going to be kicked by children, or smacked by baseball bats, or bump into each other, or fall, or just general wear and tear, bumping into each other, or their obstacle avoidance technology failing, will need to be repaired. And we say that the rise of the robots means the loss of human jobs, but really being a robot mechanic or a robot manager is going to become a very common job that you're going to see locally in cities. Big repair shops to repair all these robots from various companies are going to come to exist, or at least the companies that are operating the robots will be able to have their own microfactories to repair and maintain their own.
So it's interesting to think about how urban centers are not necessarily going to become, just centers of consumption on one end and production on the other, but also they're going to become these more circular systems in which, as you mentioned, there are going to be these robotics pools that automate a lot of the tedious stuff, and the maintenance aspect of things is just going to be a more sustainable and honestly very flexible sort of work environment for people within cities. Where do you see this where do you see this economic trend sort of taking foot first? Is it going to spread out of the Bay Area as many previous waves of technology have before? Is it going to go from different places like the Pearl River Delta in China? Is it going to go from somewhere else? What's sort of the diffusion model that you see for this new drone/robotics driven revolution? Where do you think it's coming from, and where is it going?
I believe it's going to start in Africa, probably. I see a lot of African countries and cities even have a very modern approach to leapfrogging modern paradigms and going straight for maybe the most directly useful technology available at the time. So I think that with new investments, with a lot of new investments in infrastructure coming into Central Africa, I see a lot of potential there for new logistics paradigms built and founded on robotics principles to come to fruition. I wouldn't be surprised if China also starts to experiment in some of their cities. I've noticed that, for example, Shenzhen has been a really strong ground for logistics experiments and infrastructure experiments, where China or the Shenzhen's government has tried things that I think a lot of cities would be afraid to try and or overhaul at that level. So I think that maybe special economic zones like Shenzhen in China and elsewhere in Southeast Asia are probably going to take the dip.
Yeah, so this is sort of what I was aiming at with the question, where, as everybody knows, Shenzhen is called the Silicon Valley of hardware. So I was thinking that sort of region might be the origin of various, hardware and software solutions, and the sort of playground for experimenting with this type of technology would be leapfrog-friendly places like South America or Africa for implementing these drones. So I was wondering if you could tell me more about this sort of aspect, where the centralized aspect of it, which is sort of the design, the programming, the bits, the command systems, and all of that, would be not necessarily at odds, but would be sort of separate from the distributed segment of this industry, which is the manufacturing and upcycling, as you mentioned. So in essence, what I mean to say is that there's going to be a compartmentalized system where there's centralized bits and decentralized nuts and bolts, if that makes sense. Could you talk more about that?
Yeah, I think I see what you're saying. I think in a world of microfactories, in a world where you can print out matter, where the matter is decentralized, companies that produce products are going to have portfolios of digital assets that they sell and sell again like software. Like today, we have, for example, Apple that they design a phone, and then they have a contract manufacturer, Foxconn in Asia, produce these phones to their specs. So they own the idea, they own the idea of the phone, and then it's produced by somebody else and sold. Apple has to get back into that chain. Like the phones are shipped to Apple's distribution and Apple stores and Apple's distributors and packaged as Apple products. I think that when you have all these digital assets, people that have printers, by having a printer, they are now a node in this marketplace. They can now purchase your design and create the matter themselves where they are. So rather than distribute all the product, you're now just distributing plastic, or everybody can take charge of distributing or securing their own plastic, and the ideas can travel all over the world. It's already been this way with software. It's always been it's been this way with software since we transitioned from CD medium or floppy disk medium to the paradigm of downloading software from the internet, or having software that exists only on the cloud that can be deployed anywhere in the world from a central command station of, let's say, Silicon Valley, where that company now makes money from these products that are being sold anywhere without them doing incrementally more work.
And this sounds like a very interesting problem because 3D printing sort of has this connotation with it of, these free data type of arguments where information wants to be free, and there were these various file sharing, torrenting, etc. Circles where they would be sharing recipes on 3D printing, even stuff like firearms. I'm wondering how the intellectual property aspect of this can be effectively managed, because if you're a company, let's say in Silicon Valley, and you design a drone of some kind that's open to being printed somewhere, I'm wondering how do you stop IP leakage in this industry? Because it sounds like, when you're a centralized hub of information of that type, it's sort of the only string to your bow. Without the sort of monopoly de facto or de jure that you have on those bits, you seem pretty much dead in the water. So how do you imagine this innovation sort of keeping its head above water?
So that's a really interesting question, and there's a few different approaches that I've seen that can handle this. And now the first things first, I would say that 3D printed files are being shared. You have groups like Thingiverse and GrabCAD, where people are sharing stuff that's free, all kinds of digital art that people are printing. There's basically standards among the 3D printing community. Like if you own a 3D printer, most people, when they first buy or set up or upgrade their printer, they'll print a Benchy, which is a boat. And it's called Benchy because it's a benchmark for the printer. So that file, like, everybody's got it. And if you don't, you can get it easily. And that's not going anywhere. But also, there are sites today where you can pay for and buy STL. STL file being the type of file you use to produce a print. It's like a 3D model file. So you can buy a 3D model. I guess those businesses are relying on, if you pay for it, you're probably not going to want to let other people have it for free because you paid for it. And you also don't know that many people and are not incentivized to give it away to everybody for free. That's what that model is hoping for. So it's good for maybe more niche products, but I don't think that that's going to get you that far. There are some 3D printing companies that are looking at cloud printing, which essentially allows instructions to be streamed to the 3D printers over the web. This presents the opportunity to provide data subscriptions to where, as long as you pay your bill, you can print any of these G codes, the G code being the instructions for the printer. You can print any of these from our server if you paid your monthly bill. And so the instructions for the printer are streamed live. Now, there could be problems with that too. Alternatively, you could have files stored on your local printer that are then locked by the operating system of the printer, requiring to get on the server at least for authentication before each print. So, I mean, there's problems with this, like what do you do with a failed print? How do you ask for your money back if your prints are failing? Who do you blame? Are you not maintaining the printer correctly, or is it something on the end of the provider for that printer? So now we have to ask: are we going into a printers as a service model or printing as a service model? Who owns the printer? Who maintains the printer? So now are we saying, do we have franchises of 3D printing hubs, or franchises of a global microfactory model that can be exported all over the world? Now, there's another way altogether to go about this, and that's just give away the frame or structure of your component for free. And that's something that we've experimented with at Mothership Aeronautics. We offer one of our drone airframes on our website for free, where people can download it. And we put our logo on it. So if you download our free airframe, it will have our company logo and URL on it. So you'll know to find our website and probably pay for a product later. So it's like a free market. But if they wanted to buy the guts of the drone, the electronics of the drone, they can still come to us and we can ship that to them. But these components can be smaller than the airframe and easier to ship.
So thinking about these smaller frames and microfactories, my mind is sort of going into the other direction now, which is the 3D megafactories. And I'm thinking about, sort of second order thinking, where would you have factories that create 3D printers en masse? Would you have 3D printers that make factories that make other 3D printers? You can go with this stuff forever. But particularly what I wanted to ask is how does it make sense for this 3D printing economy to develop? Because as I just mentioned, you can go into second, third, fourth order development of this type. But what's the stuff that's actually necessary to make the 3D printing economy more viable right now? I'm thinking about stuff like 3D printed houses, or possibly years from now, 3D printing massive shipping vessels, or some other megastructures of that type. What's necessary right now for the industry to evolve? What's sort of the next steps in it?
So if we take a look at the anatomy of, let's say, a 3D printer, let's also say perhaps a drone or a general robot. What normally exists is a power system. So for a 3D printer, it plugs straight into the wall. For a drone, it's a battery. You have actuators, which for a 3D printer is going to be stepper motors, could be servos, linear actuators. For a drone, it's going to be brushless motors. So these have copper wires, magnets, laminated steel. They turn the electricity into motion. Then you have the controller boards, which are silicon chip, microchips. These tend to be somewhat application specific, but they're becoming less and less application specific. We're basically seeing different iterations of what you could ostensibly call an Arduino that are having softwares that are also becoming consolidated, installed on them. So for example, with 3D printers, you have an open source software called Marlin that powers, maybe 80% of consumer 3D printers that are out there. It's an open source that everyone's using. And they build off of it and create their own proprietary stuff. But if you know how to install a Marlin, you can basically set up any printer. Same thing with drones. You have softwares like PX4 and ArduPilot, where if you've got all the pieces for a drone, you can set up this drone or that drone, or you could set up an unmanned car, unmanned submarine. A lot of the electronics are ostensibly the same. So yeah, we have the actuators, the controllers, then things like frame and wiring. These can be sourced almost anywhere. You can build a 3D printer frame out of welded steel tubes, out of aluminum extrusion, out of bamboo, out of clay. I wouldn't recommend building one out of clay, but anywhere that you are in the world, the materials that you have can be used to make 3D printers, possibly even drones. The structures are very application specific and large. It's not economical to ship these structures, because when you ship a 3D printer, let's say you ship a 600 by 600 millimeter 3D printer, you're shipping mostly empty space, but it's heavy, and that's expensive. Often for large printers, a huge portion of the cost is simply just warehousing that large box and then shipping that large space. The components that go into a 3D printer that cannot be sourced locally are maybe 10% of that volume, like the actuators, the controller, and yeah, that's pretty much it. The actuators, the controller, the hot end, like the heating element, which I suspect these can be made locally in a lot of places. A lot of the components that maybe are more specialized can be printed locally.
So the way that you're talking about these 3D printers getting developed in, getting shipped, getting developed locally, etc., they actually make me think about SEZs as sort of the corollary to them. And let me say more about that. You talk about actuators and controllers, heating elements, shipping, and all of this. A lot of that actually sounds like the way people think about development economics and special economic zones, where they think about actuators as sort of the best practices that get used in special economic zones. Then on the other end, there's the heating element, which is sort of the operationalizing management side of the zones. And the way that I'm thinking about this, and this might be sort of stretching the metaphor, but as 3D printers can be these centers of manufacturing and industry that can be popped up almost anywhere. In a similar way, special economic zones can be a place where economic development springs up if the necessary inputs and best practices are made. So it's just from a geoeconomic standpoint. Back to the name of the podcast. It's a very interesting way of thinking about how technological development sort of mirrors the civics development or social technology development that we're seeing elsewhere in the space. So, just as a sort of final stretch to the conversation, do you think that special economic zones are places where technologies that you mentioned, like 3D printing, drones, etc., could be sort of catalyzed into new engines of growth, particularly in places like you mentioned, Africa, etc.?
Yeah, I think that was a very interesting analogy, and I think that it actually works. When you look at special economic zones, you're applying concepts that work universally to maybe something more locally specific in that zone. And I think that 3D printing is definitely a good fit for special economic zones because there are some key components that need to be injected into the system to fuel that first growth, where you create the first batches of printers or the first systems that start to maybe produce your actuators or produce your machines at scale. You're the first step of industrializations. You need the first, I guess, knife to start carving your other knives.
And I think on that thought, we can sort of wrap up thinking about how there's anchor tenants that make most SEZs get launched, and then there's also starter tools that help us build other tools. And we can think of ourselves as not necessarily tool making animals, but tool making animals, if that makes sense. So sort of a second order
Yeah.
removal from there. Jonathan, I want to thank you for taking the time to talk to us today. If people want to follow you and hear more of your thoughts, where can they find you and learn more about what you think and what you do?
Yeah, they can find my company Mothership Aeronautics at www.mothership.aero, AERO, so www.mothership.aero, or find me, Jonathan Nutzati, on LinkedIn.
Awesome, thank you, Jonathan. So, if you want to find us, you can find us on YouTube at Adrianople Group. You can find us on Twitter at Geoeconomics Pod. We'll have all the relevant links in the description. Thank you for listening, and we'll see you on the next one.